David, thank you very much. And I think you did a wonderful job aligning these presentations, the order that you put them in. As Peter mentioned that Dow Chemical had to answer the question as to whether or not we could get this stuff out of the ground. Guess what we do? We make the stuff that goes into the stuff that gets it out of the ground. And I don't care if it's wet gas, dry gas, crude oil, or whatever. If we're putting a hole in the ground somewhere, my steel's going to be there. Again, my name's Tom Moline, and I'm the head of manufacturing for the Timken Company's steel business. I'd like to thank the Canton Regional Chamber of Commerce and the repository for giving me and the Timken Company the opportunity to share with you how significant the oil and gas industry can be to our business. The world's industrial machinery depends on Timken for reliable, efficient performance. Every day we take on the world's toughest challenges by applying what we know and what we've learned to provide products and services that help our customers solve problems. That's what we do. A little bit about the Timken Company. We are a leader in friction management and power transmission for markets that include aerospace, mining, rail, construction, automotive, distribution, and of course, energy. Our company was founded in 1899, and we are headquartered right here in Canton, Ohio. In 2012, our sales were just over $5 billion, and we have approximately 20,000 associates globally, and with operations in 30 countries. At Timken, we operate in two groups. The Bearing and Power Transmission Group, which includes three business segments: mobile industries, process industries, and aerospace, and the Timken Steel Group, which makes high-performance alloy steels for forging and machine components. We offer a full portfolio of bearings, high-performance steels, mechanical power transmission components, and related products and services. Steel applications specific to the oil and gas industry include parts that make up the horizontal and vertical drill strings on the exploration side, and parts for completion tools on the completion side. And I'll talk more about those components in a few slides. In our steel business, we focus on engineering steel to add strength where it matters, to service industrial, mobile on highway, and oil and gas markets. The tougher and more demanding the environment, and there isn't much tougher than oil and gas exploration, is where we perform best and most certainly where we want to be. Our annual melt capacity is more than 1.7 million tons, and our steel is recognized worldwide as among the highest quality, highest performing, most reliable air-melted products available. Make sure. Pardon me, it's difficult to see. We make more than 450 grades of carbon, alloy, and microalloy steels in the form of seamless mechanical tubing, specialty bar and billets, and bottom poured ingots. We also offer some value-added solutions in the form of annular components, primarily going into the automotive industry. We make a very broad size range of tubing and specialty bar, ranging from 2 to 13-inch tubing and 1 to 16-inch solid bar, and long lengths from 10 to 40 feet. That size, that combination of size and chemistry range is unmatched by any other specialty steel maker in North America. As I said earlier, our focus is on areas and industries that require very demanding steel properties and characteristics. You won't find our steel in low-performance, more commodity-type applications like reinforcing bar, hand tools, fasteners, shopping carts. But you will find our steel in high-performance applications such as, well, obviously bearings, crankshafts, fuel injectors, gears, transmission components, gun barrels, power generation equipment, and most certainly oil and gas, drilling and completion equipment. Now, how do we engage the oil and gas industry? From our steel group, our specialty bar and seamless tubing and other products are widely used by manufacturers that support this industry. And these are, without question, some of the most demanding applications, having to perform in the harshest of environments, from several thousand to tens of thousands of feet deep in the earth and in the sea, where we have very high temperatures, high pressures, high torque, extremely corrosive environments where components can't fail. And again, that's where we want our steel. And it is there in critical components like swivel joints, Kelly bars, heavy wall drill pipe, drill collars, mud motors, drill bits, and many, many more applications. And again, I'll show you some of these drill string components in a few slides. From our bearing business, Timken earned its oil field leadership position in the 1940s, designing swivel main bearings and tapered configurations for land rig crown and traveling blocks. Those designs set many lift loading specifications and standards that still remain in effect today with the American Petroleum Institute. All these years later, demand is greater, stakes are certainly much higher, and technology advancements have pushed application limits even further. We work very closely with rig builders and operators to understand these aspects of the industry and continue to engineer and manufacture solutions that provide the ultimate in equipment life and capacity and power. Every time we increase our bearing load ratings, it automatically enhances application performance in oil and gas operations. But be it the steel group or the bearing group, our commitment is to be the global leader in providing technical expertise to the oil and gas industry. Our engineering and high-quality manufacturing capabilities will deliver premier products for offshore and onshore drilling applications. And we definitely recognize that reliability and safety are the most important requirements facing today's oil and gas industry, and our solutions are specifically designed to enhance equipment reliability, improving uptime, and improve safety, increasing worker and employer peace of mind. That's a little bit about who we are, and now I'd like to talk just a bit about the topic at hand. There is no question the world needs energy, and the world is going to need a greatly increased energy supply over the next 20 to 30 years. The world's population has grown by over 2 billion people in the last 25 years, and there's no argument suggesting that this isn't going to continue to grow. Current estimates from the U.S. Energy Information Administration are for an approximate 40% increase in energy demand in the next 20 years, from 500 quadrillion BTUs to over 750 quadrillion BTUs. The infrastructure explosion in developing countries, the BRIC, Brazil, Russia, India, and China, will drive global demand for energy, and most recent studies indicate the growth will come from all sources: natural gas, oil, coal, and others such as electricity. And natural gas will likely have the highest growth rate of the group. And relatively speaking, natural gas consumption is better for the environment as it produces 50% less carbon dioxide than coal per kilowatt hour. This chart illustrates forecasted world energy consumption through the year 2035. The OECD, which is the Organization for Economic Cooperation and Development, and this upward trend represents an expected, again, 40% increase in energy consumption by 2035, most of which will come from the developing countries, again, the BRIC, with some modest growth in the OECD region, US, Europe, Japan. I particularly like this slide. Our oil and gas group, that being the Timken's marketing group for this market and industry, has recognized several factors, or what they refer to as mega trends, that we see as drivers for the energy industry for years to come. One being offshore drilling continues to find reserves in deeper, harder to get to places. There has been a 43% year-on-year increase in offshore Gulf of Mexico drilling activity, and they're going very, very deep, 7,000 feet through the sea, and then an additional 20,000 feet deep in the earth. Just amazing. I like this slide even more as it's much, much closer to home. Large shale discoveries containing natural gas have been made in several states, including the Marcellus and Utica shales in Pennsylvania, West Virginia, Ohio, Maryland, and New York, the Haynesville in Louisiana, Texas, and Arkansas, and the Barnett in Texas, that significantly increase the estimated reserves of domestic natural gas. That when mined, will likely eliminate our dependency on imports and liquid natural gas. Some experts suggest that the U.S. will be a net exporter of natural gas in less than 5 years. And as Peter mentioned, several liquid natural gas terminals have been approved for completion over the next few years, advancing exportation opportunities. Compressed natural gas is also getting a lot of attention for cross-highway domestic transportation. We need to build the infrastructure, but it's happening. Interestingly enough, the head of our shipping department was just recently approached within the last couple of weeks about putting a CNG filling station at one of our steel plants here in Canton. Shale deposits containing crude oil are found in several areas as well. The Bakken in North Dakota and Canada, the Eagle Ford in Texas, and the Utica Shale in Ohio, West Virginia, Pennsylvania, and New York. The traditional center for oil tool manufacturing is still in Houston. However, a growing portion of this capability is moving to other regions of the country and the world to get closer to the drilling activity. As the drilling activity matures, we'll see more aftermarket activity closer to the drillers, repair, refabrication, distribution. And supply chain management is also becoming increasingly important as manufacturers and producers continue to look for ways to improve and cut costs. Now, why is shale drilling important? It's important because these shale formations, as you've heard, hold very, very large reserves of natural gas and crude oil. Natural gas reserves are typically found between 3,000 and 8,000 feet, and current drilling techniques and technology, horizontal drilling and hydraulic fracturing in particular, now enables us to access those reserves. The northeastern United States holds massive amounts of natural gas that are largely untapped in the Marcellus and Utica shale formations. The Marcellus shale alone is the second largest natural gas discovery in the world and could conceivably supply the United States for many, many years. Drilling continues in the Utica shale to map the hotspots for dry gas, mainly in the East Utica, wet gases in the central, and also spots for oil. And the Bakken shale in North Dakota is now producing 500,000 barrels of oil per day. United States natural gas production is beginning to close the gap with United States demand, and shale production increases is helping to close that gap. 0% of natural gas production came from shale deposits in the year 2000. We've increased that to 40% currently, which will most certainly help reduce dependence on imports, particularly from Canada. We're seeing an increase in crude oil production due to shale drilling, mostly in the lower 48 states. In 2014, we'll produce more than we import. And OPEC production is falling as a result of this growth in North America. Certainly another step in the right direction of energy independence. This very simple chart illustrates how drilling activity drives demand for some of Timken's products. The blue line is U.S. drilling rig count, and the orange line is our steel shipments to this industry. So why does Timken care? Other than it drives demand for some of our products, which is the last bullet on this slide. But it's also very good for the economy in general. The oil and gas industry supports more than 9 million jobs and contributes more than 7% of the total gross domestic product. In Northeast Ohio, the drilling activity will need a support infrastructure, a need for engineering and general service resources, drilling component distribution centers, and demand for general infrastructure, anything from housing to offices and so on. The exploration technology is proven. It has been advanced and used safely for over 60 years in the Barnett Shale in Texas. It is very highly regulated by the Department of Energy, the Environmental Protection Agency, state and local agencies, and that should and will continue to ensure that technology and safety advancements continue. The competitiveness of U.S. manufacturers, and most certainly steel makers, is closely linked to low-cost, environmentally friendly energy sources. And this shale play will help the U.S. become a net exporter of natural gas, as well as reduce our dependence on foreign oil. And by the way, as a steel maker, we are a very large consumer of natural gas, not to the degree that Dow is, but we're a large consumer. This is a chart of our steel plant's annual consumption of natural gas. We use about 5 million MCF per year. That's 5 million thousand cubic feet per year, or more simply said, it's 5 billion cubic feet of natural gas every year goes into making steel in our steel plants right here in Canton, Ohio. And believe me, I very much remember when natural gas was selling for over $12 an MCF, as compared to $3.50 today. Here's a slide of the many applications that make up horizontal and vertical drill strings: toll joints, stabilizer bars, drill collars, heavy wall drill pipe, rotary drill bits, fixed outer drill bits, and so on. There's a lot of specialty steel in these drill strings, and we supply into all of it. Again, it's not an easy place to participate. The applications are demanding. Obviously, there are very harsh conditions with high forces, high pressures, very high temperatures. Material requirements are exacting, and the price of failure, well, it's very, very high if you have a failure in one of these drill strings. There has been a significant shift from the more traditional vertical drilling method to horizontal, which now accounts for about 70% of the active drilling rigs in North America. And here are some of the many applications on the completion side. After the drilling and fracking are complete, couplings, pup joints, swivel joints, wellhead forgings, and also a few deep water applications, riser tubing, subsea blowout preventers. Again, a lot of specialty steel on the completion side, and we supply into all of this as well. So that's a little bit about who we are and why the oil and gas industry is important to us. Now I have a few slides to talk about how we do it and a little bit more about what I do. Our raw material manufacturing to support the oil and gas industry is done right here in Canton at our Faircrest, Harrison, and Gambrinus steel plants. We do some value-add manufacturing at Timken Boring Specialties in Houston, Texas. We also warehouse some long products for oil and gas markets in China and Mexico. We commissioned our Faircrest steel plant in 1985 as the most state-of-the-art technologically advanced steelmaking facility in North America and probably the world. We melt, refine, cast, and roll solid steel bars at this plant in sizes from 5.5 to 16 inches in diameter. And today our capacity at this plant is just over 1 million tons per year. The original design capacity for this facility was 500,000 tons per year. We have doubled that capacity to over 1 million tons in the last 25 years without any real significant capital investment, but mainly through the continuous improvement efforts of our workforce. But we've exhausted that CI opportunity with the existing equipment, so today we're in the process of investing heavily in this plant, nearly $275 million in upgrades to melting, refining, casting, forge rolling, and finishing operations. And we're doing this to significantly increase our capacity and capabilities to serve the markets where we want to be. And the oil and gas market is playing a significant role in that expansion effort. And I'll show you a little bit about what that looks like. This is our Faircrest steel plant. The steel melting shop is at the top, the rolling shop is in the center, and the finishing facility is off to the left. We're adding a second refining station, a jumbo vertical casting machine, a large forge press in line with our rolling mills, and a highly sophisticated surface and internal inspection unit. All in, again, this is about a $275 million investment to increase the Faircrest plant capacity by 25% and advance our capabilities for the production of more exotic steel grades and large cross-section sound center bars. This is the jumbo vertical casting machine. It's massive. It'll stand 265 feet tall, 80 feet below the ground, and 185 feet above the ground. When complete, it will be the largest vertical bloom casting machine in the world. It'll provide 125,000 tons of additional plant capacity and also provide superior segregation control relative to our existing casting methods. This is the marquee piece of equipment in this particular expansion and accounts for $200 million of that investment. This is what it looks like today. We've been at the construction phase for about a year now, a little over a year. We still have some work to do, but it will be operational next summer. The second ladle refining station is a duplicate of an existing machine we're already operating in the plant. This second station is critical in that it eliminates current production bottlenecks in our steelmaking operation, providing 40,000 tons of additional capacity, and it also advances our capability for making these complex and exotic steel grades. The refining station was commissioned in May of this year. It's fully operational. It was a $25 million investment. We installed a high-volume forge press in line with our rolling mills. This was the first of its kind in the United States. It'll provide 40,000 tons of additional capacity as well, with operating efficiencies and modest yield gains in our rolling mill, and advance our capability to offer guaranteed solid center product and much larger cross-sections than we can do today. The inline forge press was commissioned in January of this year. It is fully operational, and it was a $35 million investment. All right, they threw this chart. This chart shows how the center of the bar product is healed up through the forge roll process. We forge first to get good internal soundness, which is the bright section in the center. You see it getting smaller and smaller as it goes through the forging and rolling process. But the rolling then offers for superior shape and size control. Again, unique to us in North America. And lastly, we added a new bar inspection machine that will perform both a surface and internal inspection to ensure that we achieve the degree of center soundness we expect from the forge roll process in the mill. The inspection unit was commissioned last summer and is fully operational. It was a $5 million investment. So that's the Faircrest Steel Plant expansion effort, but we aren't ignoring our other facilities. This is our Gambrinus Steel Plant. It was commissioned in the late 1920s. It's not a steel making plant. It's primarily a tube manufacturing plant, and we do all of our heat treating at this facility. We have 3 tube mills that use oscil and plug mill technologies to produce sizes 2 to 13 inches in diameter with a capacity of about 425,000 tons per year. We've been investing here as well with $70 million in upgrades to our piercing, heat treat, and finishing operations. The marquee piece of equipment at this plant is a new intermediate finishing line that incorporates the latest technologies and lean processes. This largely eliminates product touches and material movement, significantly improving safety and manufacturing cycle times. These state-of-the-art finishing processes include straightening, water blast scale removal, which eliminated acid pickling, very good for the environment, cutting, ultrasonic testing, eddy current testing, and dimensional gauging. The technology advancements employed into this finishing line have proven to be absolutely critical to efficiently and effectively satisfying the exacting specifications of the oil and gas applications. And we are the only company in North America to operate a facility like this for our tubing. Indeed, a game changer. The finishing line was commissioned in February of this year and is fully operational, and it was a $50 million investment. This is our Harrison Steel Plant. This was our first steel-making facility, commissioned in 1916. We melt, refine, cast, and roll solid steel bars in sizes from 1 to 7.5 inches in diameter. Our capacity at this plant is just over 750,000 tons. We've invested recently in this plant as well, with about $100 million in upgrades to melting, rolling, and finishing operations. The marquee piece of equipment at this plant is a new precision sizing mill that incorporates three-roll rolling technology with hydraulic gate control. Again, the first of its kind in North America. It's provided 140,000 tons of additional capacity and advanced our capabilities to roll sizes from 1 inch to 5 inches in diameter to the tightest size tolerance control requirements in the industry. We commissioned this line in late 2009. It's fully operational, and we spent $60 million on this piece of equipment. In 2008, we acquired Timken Boring Specialties in Houston, Texas. This plant is almost completely dedicated to the oil and gas industry. Timken Boring Specialties is a specialty finishing plant. They use our bar and tube products made here in Canton as raw material feedstock, and they are a leading provider of precision deep hole extraction products for the oil and gas drilling and exploration. So, we've made significant investments in our focus to meet customer needs, market needs, and most importantly, to position ourselves to be a leader in our space for oil and gas applications and many more. All in, the investments we've made and are in the process of completing will exceed more than $500 million. We accepted the challenge to be the best. We are very committed to this. Peter, we very much understand the supply side of things. We put the capacity in place to deal with that. And we look forward to allowing the world to show us, or to show them what we're capable of doing. Now, they threw this slide. This slide's, it's interesting just to illustrate the magnitude and the reach that the equipment additions we're making has on various industries and certainly our community as well. This is just a snapshot of the amount of structural steel and concrete that went into the equipment adds at Faircrest. So it's not just buying a large casting machine and slapping it in place out there. We used over 36,000 yards of concrete to build the foundation for this machine. All came from local cement companies. So, in closing, developments in the Utica Shale are indeed shaping an energy-rich future for the world. The world needs energy, and U.S. manufacturers, particularly steel makers, will play a big role in ensuring that the world gets what it needs. Thank you. I'm happy to entertain any questions you may have. I will preface this by saying I just make the stuff. I am not the marketing front-end business guy. I'm reasonably well-versed in that, but my expertise is more on the manufacturing side.
Tom, thank you very much. Many of us were not aware of the extent to which Ohio was involved in oil and gas until the Utica came along, because the vertical oil and gas business was rather low profile. But I've heard that the original investment in Faircrest was driven to some great extent by your desire to supply oil and gas. Can you talk about that investment that many people thought was a risky investment in the early 80s when nobody was building steel mills, and how much oil and gas drove that decision?
Yeah. It was a challenging decision to make. As I said, we commissioned Faircrest in 1985. We started building the plant in 1981. It was a $450 million investment at the time, which, quite frankly, was 2/3 of the net value of the Timken company at the time we launched that project. So yeah, they bet the company on it. And they bet it on going around the world and finding the most state-of-the-art technologically advanced steelmaking equipment available and putting it at one facility. And what did we do it for? The oil and gas market. Absolutely. We expected to make a lot of long, solid bars that would wind up as drill collars and different coupling type tools that were going into primarily the West, into Texas, for deep hole drilling for natural gas, when we used to have to go down 35,000, 40,000 feet to find natural gas deposits. as well as oil. You don't have to go as deep for oil, but that plant was specifically designed to go after the oil and gas industry. Then it collapsed. We took a break. We took a year off from the project of actually building that facility. The market started to improve. We came back online, started it up, and one of the best decisions the company ever made.
Thank you for that. You also talked about Texas and Oklahoma as being the center of oil tool manufacturing, and I presume that means they would buy your steel and make the tools there for the industry. And you also talked about the potential for that tool-making industry to migrate to other places. What do you think the chances are of a state like Ohio, because of the Utica, attracting those kinds of manufacturers of your materials into tools?
It will happen. It may not happen quickly on the actual manufacturing side. What will happen quickly is the aftermarket. Refabrication of tools, repair of tools, distribution centers for tools. That'll happen first. Okay. And it's already happening.
I'm looking for questions from the audience. Joe? We have a lot more reason to be prepared.
Tom, thanks for the presentation. Well, one of the purposes of this conference is to say companies have to look forward and kind of make the bet. And obviously, Timken's been very successful in doing that in the oil and gas industry almost for decades. Looking at that 25% expansion that you're doing, how long do you project out without being able to serve the demands of the industry? Another 5 years, another 10 years?
Again, based on our market trend analysis, I state that we're advancing our capacity at this plant by 25% because that's how I built the business case, and that's what we're going public with. As I told you earlier, when we started up Faircrest, design capacity for that plant was 500,000 tons a year. Without any significant capital investment, we doubled that. Do I think I can go beyond the 25%? You bet. Will I? You bet. Will that carry us into the 2030 to 2035 type range as far as supply is concerned? That's what we're forecasting.
Here. Yes, sir.
Thank you very much for your strong, optimistic presentation on your company. I'd like to ask a very simple question, like what would be the number one problem that your company faces in creating more jobs, not only here in Ohio, but for the rest of the world?
Well, let me speak specifically to Ohio first. Job creation isn't so much a difficult challenge for us right now. Our challenges are more around finding good, solid technical talent in the area or attracting it to this area, particularly engineers and technicians and folks of that nature. Our challenges are more in attracting and retaining strong talent to do the types of things we do than job creation right now. We're in the, as a manufacturer, I'm more in the market of sustainability and job security for the workforce that we have employed in our plants. We are very committed to continuous improvement efforts that do result in some labor efficiencies, but it also very significantly increases our competitive position in the types of applications and markets that we participate in, securing jobs for our workforce.
Tom, I'll have one more question. Your company, especially at senior leadership, has been very active in promoting manufacturing in general, encouraging manufacturing in general, promoting policies that encourage manufacturing. In this energy-rich environment, how much do you think the growth of hard manufacturing will be encouraged by things like gas prices beyond your particular steel operation?
It's kind of when I look at it, particularly with gas prices, as I shared with you, we're a major consumer of natural gas in our steel plants. So seeing natural gas prices go up isn't something that particularly gives me, a good feeling or a good sense. But if that's happening, that means we're going out and looking for more. We're doing more exploration, we're doing more drilling. That's very good news for me as a steel maker and our company as a steel manufacturer, because we're making all of the steel that's going into the components that go into the drill strings that define the stuff. So seeing natural gas prices increase, while not good from a pure operating cost perspective, it's very good from a market perspective. It's very good from a top line perspective for us. Did that answer your question?
Very good, thank you. Join me in thanking Tom Moline and the Timken Company for being with us today.
Thank you.